Hi, very good morning all. Welcome to Performance Engineering Training Program, which we do it in 22 days. As part of this particular demo session, I'm going to explain you about how we drive this program, what is that we cover, and what is the end result of this course mainly. And we will also explain you from where to start, what is the exact roadmap for people who already have experience with multiple tools in performance testing, like different versions of load runner and different versions of Apache JMeter or NeoLoad, be it Locust or Gatling, whatever the tool that you use. We are going to teach you something on performance engineering, on identifying the bottlenecks, assessing the performance of every individual entity that is part of your environment, architecture, including external components, internal components, all of that. So we'll explain. Okay. Coming to my profile, I am Radhakrishna Prasad, and I have close to 14 plus years of experience in performance testing, performance engineering, site reliability engineering, and application performance management, observability in full stack, monitoring everything end to end. So I have been working with many teams, many organizations, be it services, products. I was also a part of consulting practice teams, COE teams, and other tools teams where I have been working with multiple business units like banking, insurance, healthcare, manufacturing, all of that. So my primary role was actually identifying, fixing the bottlenecks, creating solutions, creating the roadmaps for all the customers who really don't know from where they have to start with respect to performance testing, performance engineering, setting goals, identifying the bottlenecks, interpreting the results, deriving what went wrong, how it went wrong, all of that. And coming to this course, if you ask me who this course is for, this course is basically performance test engineers who are actually limited to something called performance testing, who are actually doing some traditional performance testing like collecting the NFRs, then preparing a non-functional test plan, then doing some types of tests for execution, getting the report from analysis, adding some monitors and sending it to the customer in the way they want. Okay. So beyond this, what we are doing is we are going to talk about some of the real case studies. We are setting up a lab so that you can create you can take multiple GCs, GC logs, thread dumps, heat dumps, AWR reports like the way you do in real time. So this particular course is for performance engineers, developers, as we teach code profiling, architects, DevOps people from APM tools, few SR engineers, and anyone moving towards performance engineering on understanding systems, right? Improving the efficiency of the systems, improving the efficiency of the systems, working on continuous improvements on all the different system level, user level, operational level, network level, server level, for anything you want to do as from the performance engineering, this course is for them. Okay. And also when we talk about the skills, right, it's just not that we are just giving you some holistic insights or a high level thing that is giving you some experience which you can add to the performance testing experience which you already got. But what skill you gain, it is all about how do you need, how do you collect NFRs, how do you design a performance testing, what is the outcome, how do you need to set the performance goals, okay, what are the different SLAs, KPIs, how do you need to prioritize them within the timeline that is being given, and considering the current emerging tech stack that is being asked from different people, from different stakeholders across different companies. So we will give you that insights on understanding how systems has to be tested. Okay, what is that you really need and how you need to interpret. For example, most companies today they're running the load tests just before the release, right? but still applications are getting crashed in production during festival sales, or if the sales are increasing, or if you experience peak traffic. Why does this happen? Because most of the companies are still running load testing, which is not sufficient. So now what and why organizations need performance engineering is what you learn. Okay. The performance testing, what you're doing today is not exposed to many of the other areas, other skills where you're restricted to do only traditional performance testing. We are not even doing the right workload modeling. We are not exposed to something called capacity planning. We are not exposed to something called, you don't have access to the complete dedicated performance testing environment where you can see the performance of the code. You cannot, we are talking about many tools like JVisual VM, JConsole, or JMC, JFR. But in real time, what is the point? Where is the place you are actually trying to leverage those tools to tell them that a particular method or a particular line of code is actually consuming 80% of the CPU or 60% of the memory? So this session, right, will give you that level of knowledge, and it will make you like an experienced person, which will make you understand the performance testing and performance engineering gap, understanding the differences between dedicated performance testing environment on what you have tested and the instance that you are experiencing on the production systems. Okay. And we are primarily focusing on um, the root cause analysis, the system level thinking, and analyzing everything, understanding everything from the OS level. If I talk about application server, we are talking about multiple application servers for Java like Apache Tomcat, Oracle WebLogic, IBM WebSphere. We are talking issues from the operating system level on the application server, and we dedicatedly talk about something called JVM in .NET, JVM monitoring, the problems of JVM for all the Java applications. If it is .NET, like JVM in Java, we are talking about something called CLR, which is Common Language Runtime, which acts as an execution engine for .NET applications. Okay. Similarly, we are also talking about the databases, which is Oracle, MySQL, and SQL Server. So we have two applications. One is Java, where we are going to deploy an Apache Tomcat and we'll connect that to MySQL database server. In .NET, we have an IAS server, web application server, which we are connecting it to MySQL server. Okay. So we will be working multiple servers. We will create a setup end to end. We'll implement everything end to end. We will record scripts and we will execute them on the real systems that you will be deploying. So we'll make you to create your own lab setup on your personal laptop. If your personal laptop is having good configuration, like i7-16GB, you will be able to create an application server. You'll be able to deploy that. You'll be connecting it to the database server. You'll be able to create some 30 to 40 GB of data on that. We'll increase the volume of the data on the database. You will create user IDs, and you will create some user journeys which you will record, and you will execute tests with 40 users, 50 users, and you will try to see many of the performance issues, and we will talk one by one. Okay. And coming to the monitoring part, we also last batch, this batch, we have explained about how to install agent on the application server, database server, and web server. We have used Site 24x7. We have used New Relic. We have used uh, Manage Engine Application Manager. More or less, we have covered close to 3 tools, and we clearly explained on how to install agent, how to gather metrics, how to take the reports, how to create dashboards, all of that. And if you ask me my mission, right, I have seen many people facing difficulty on what is being asked from different companies. Okay, if you have 10 years, or if you have 5 years, or if you have 15 years, I'm working in one project since last 8 years, 9 years. When companies are asking something, I really don't know for what are the areas that I need to prepare, uh, how I need to project my skills in my resume. So how do I need to uh, target or apply for multiple positions above 14 years experience? So what is that you really require? So people are asking you, uh, if you go with one cloud today, right? You'll not be able to get an entry schedule. If you go to Microsoft, right, for a performance engineering interview, they'll ask the experience on .NET application, .NET Core. Then they'll have ask experience with IAS server, which is a .NET product again, and they are focusing on a database called Microsoft SQL Server. So the evaluation will be restricted to 80%, 70, 80% will be restricted to their own Microsoft products, which is IAS, .NET Framework, ASP.NET Core, MVC, IAS Web Application Server, Microsoft SQL Server, and if they are asking cloud, they'll ask you something in Microsoft Azure Cloud. Okay, Azure App Insights. So on the other side, even if you have experience on SAP performance engineering, SAP performance testing, database replication performance testing, or if you have been working with extensively on optimizing the databases since last 8 years, sometimes these skills will be of no use. With the adoption of the new AI tools, when you apply for any specific position, you initially need to get the information of the JD, and you need to change the resume accordingly, and you need to hit it. You just don't need to put that in uh, Naukri or Indeed, and you should not make it common. You need to understand the JD. You have to accordingly streamline, make changes in your profile, and you have to shoot that. But again, when it comes to performance testing and performance engineering, some 65 to 70% skills that are common, that applies to everybody. Load runner is common, geometry is common, JVM tuning is common. Okay. Working on application servers is common. Java applications performance optimization is common. Client side performance testing is common. Database performance monitoring, performance uh, engineering is common skill. And the recently asked skill is like the implementation of CI/CD. They'll ask you how did you automate something by doing a test, getting the report, all of that. And there are some skills. Okay, cloud is mandatory. Cloud has become mandatory now. And again, it depends on which cloud. Okay. So my mission is to help every performance test engineer who is restricted to performance testing with some tool, some X tool or Y tool. I'm going to define the roadmap, and I'm going to move everybody into performance engineering, and you own a title called performance engineer. It's not just a performance tester or performance test engineer. When you call yourself a performance engineer, it is like you will be working on a every single stack. Let's say you are taking AWS report today. You want to know what's happening on Oracle database, you are taking AWS report today. Even who is the Oracle database administrator, who is the Oracle guru with 15 plus years of experience, it is very hard for him to understand what went wrong, where it went wrong, why it went wrong, and what is that he has to fix immediately to eliminate some bottleneck on the database. No, it cannot be done. You have to correlate multiple sections, multiple metrics, and you have to see what value is increasing with what. And you have to derive a conclusion, draw a line saying that this value increased with this value, this is the problem, and this is what I'm reporting in the report. That is what the performance test engineer is doing today. So when it comes to performance engineer, when you call yourself as a performance engineer, if you ask me what skills are required, yes, you need skills on you need 20% of the skills or 25% of the skills on networking. If you don't know what is TCP/IP, if you don't know what is TCP/dump, if you don't know what is packets per second, what is packet drop, what is network latency, you really don't understand, or you will not gain that ability to identify the network related problems. Similarly, if you don't have the basics of database, you don't know what is DML, Why do we use avoid selects in the query optimization you are doing? You need to avoid a select. Why you need to avoid a select? Select star from employees. You're calling everything. You're fetching all the data, all the rows and all the columns. But you're using select star without select star, select employee ID, employee name from employees. You are only taking two parameters, whichever is required, right? So when it comes to performance engineering, 20 to 25% of the skills from every area will be required, and it becomes mandatory to start your analysis part. You need to have experience, some knowledge on networking concepts, on databases, on WebLogic servers, on application servers, sorry, on web servers, on messaging brokers. Many of you are now using Kafka or ActiveMQ or RabbitMQ. There will be one goal. Earlier, my application is not having a messaging broker. Now I am implementing messaging broker. Now my performance objective or goal is, when you test it, you need to assess the performance of the Kafka, impact of Kafka. Eventually or parallelly, you also need to assess the performance of other components that are already there in your architecture. Because adding Kafka will definitely bring some percentage of negative impact on the other components which are already working fine earlier. So you need to do performance testing, multiple rounds of performance testing. Keep this in as an iterative process. Target Kafka, optimize Kafka, and do a performance regression to see other components are also in sync with respect to performance SLAs. We have to ensure that they are within the acceptable limits, acceptable SLAs along with Kafka SLAs. Okay. Now, the introduction and context is this. Okay. If you ask me, explain what is performance testing, performance engineering. Today, you're doing only tool execution, which is limited to traditional performance testing again. We are taking you to the system thinking, which is performance engineering. Let's say I can explain you the slide, but my focus is not on the slides, but I'm going to show you the slide, what we are going to cover. You have an e-commerce application working fine with 100 users in load testing, but today it is crashing when it is experiencing 5,000 users. What could be the reasons? Anybody? You are testing with 1,000 users, you're dropping it, saying the customer, this is the report with 100,000 users, your SLAs are met. Today, I'm talking about the same thing. The application went to production. Now it is live in production. It is experiencing only 800 users, which is less than 200 users on what you have tested. Now they are experiencing 8 seconds of response time for a single transaction like add to cart. Can you tell me what could be the reason? Anybody?
It could be anything based on the load and the network, and
Right.
there will be, yeah.
So it could be anything. Example, your database is slow, your thread pool got exhausted, you may have problem with caching, there could be a problem with network. For example, if your web servers, application servers are in USA and database servers are somewhere in downside Canada, you will have a latency issue. We have been doing something like that, where we have application servers and database servers in one place, which is USA, from rack space because of the cost aspects. Now, application servers are sitting in USA. Now, database servers are moved to downside Canada, where it has to increase the latency when you send a request from application server to database server. So here we are teaching why performance engineers, what is performance engineering, what is the role of performance engineering here in such scenarios, what is the differences, why performance engineering is critical. So we will explain the difference clearly. For example, you have an performance testing assignment. You're using JMeter, you're using load runner. Simple, we'll start from basics. You are doing a test with 100 users test, same script, same settings, you're running a test, right? When you're running a test, what happens? You did the same thing in load runner, JMeter, and NeoLoad. All the three tools have given you three different response times. Which tool would you select and why? Let's say many of the customers are now using load runner and JMeter. Now my NeoLoad has given me very good numbers. I am, as a performance engineer, with my experience 6 years or skills I got, I'm telling NeoLoad gave me the best numbers. Now, the customer will not think about the merits and demerits of using is of using a specific tool, or nor is worried about cost expense. He's not worried about money. He's simply understanding that you used two tools in the POC. You got best numbers for NeoLoad. Why don't you use NeoLoad? Now, as a customer, I am forcing my performance team who already got 12, 13 years experience. I got 11 members in my team. I'm now saying I'm use NeoLoad. Now, what is your interpretation here? What is that you want to tell me as a performance engineer to the stakeholder? You understand my question? And also, these sessions will be much more interactive. It will go from basics to the moderate level discussions, along with complex real world scenarios and best practices. So we will also expect the candidates to be much more interactive. It can be a basic answer, it can be a silly answer as part of learning process. We would expect you to be more interactive to gain more insights, uh, lots of knowledge and other, so that when people are more interactive, right, we'll be able to discuss more number of scenarios. So now you got my question. What is it? What is your answer for that? Okay, I'll not force you. So this is something that can, there are certain things when people ask you, right, they can immediately stop you from getting selected. You don't get blank. At least whatever you want to communicate or convey it, you just start giving me some answer. It can be anything. So performance testing, you're selecting tools, JMeter, load runner, you're generating a load, creating a scripts, check response tips, done, giving a report. Now, what is the role of performance engineering? When I'm saying performance engineering is critical, you are assessing the performance architecture. You sometimes you design in performance engineering, you will design a performance model from scratch. What is performance model? The mirror image of what you have in production, the exact replica of what you have in production. Every single component. For example, you're sending a request, you have a user, then you have a firewall, you have firewall settings, right? Then you have load balancers, you have software load balancer, hardware load balancer. Then you have proxy servers, reverse proxy servers. In some applications, you have API gateways, file servers. You have service mesh, you have Kafka, RabbitMQ, Docker, Kubernetes, web servers, application servers, database servers. Some applications are connected to cloud. Okay, some applications are containerized, some applications are on-premise, monolithic, cloud. When it is a big application like banking application like Bank of America or wealth management applications, you have multiple applications pointing to different databases. Like some of them are cloud databases, some of them are SQL databases, NoSQL databases. Now the most trending databases, which is vector databases. So you will design performance architecture. You will be involving in capacity planning. You will be involved in defining the monitoring strategies. You'll perform root cause analysis, and you'll be performing tuning across various levels. A real example is you have a banking application. For example, you're testing an application with 2000 users. Your SLA is 2 seconds. CPU is 40%. Now you say that my application and database resources are too good. My SLAs are less than 2 seconds when I tested with 2000 users. And you're saying that the result is passed. But whereas in performance testing, Whereas performance engineering, in the production, the same application with 2000 users, the response time is users are experiencing up to 12 to 15 seconds. CPU is not 40%, it went up to 90%. Finally, it is crashing the system. Why? You may discover some reasons like database connection pool exhausted, JVM, you're having high GC pass times, you're having explicit GC. Then you have explicit logging, which is bloating your log files on the database server and it is crashing your application. That is your assumptions. But the real problem is the gap between the performance testing environment and production environment. Today, if you go back and check your applications, on the environment where you're actually testing, you will not have load balancer. You will not have balancing algorithms that are set like round robin, uh, least round robin, random. Uh, so there are some load balancing algorithms. There is no CDN. There is no DNS. There is no existence of DNS. You will not have the same software hardware configuration of the web server, application server, or database server. You will not have caching enabled. Yes, most importantly, database. Your database will have so many activities that are happening inside a production, but whereas in your performance testing environment database, today you go back and look at the database, your database will become active only when you put load on it, when you run a test on it. Okay. So performance engineering life cycle, if you look at the SLAs and common performance issues, the end-to-end process, even many of the tasks that are shown in this slide, you will be missing. Collecting the requirements, maybe sometimes it is straightforward from the customers. The second case is you don't even have a single metric. You have to do everything from scratch. You have to define the SLAs. You have to define the workload model. You have to design the performance testing. You have to design the monitoring, then root cause analysis and tuning. I am your customer. I'm saying that my SLAs or KPI is my login should be 2 seconds. Doesn't matter with how many number of users you test, what configurations you use. My peak users are 5,000. Concurrent users are 800. Now again, you have to understand some basics here. I'll not explain you that. What is the difference between peak users and concurrent users? What is bringing that impact? Peak users are 5,000 when my concurrent users are 800. My login transactions should be 20% of the overall load. There is search 60%, checkout 20%. So without workload modeling, if your workload modeling is wrong, everything is wrong. The load tests will become unrealistic. Okay. So you also need to understand the difference between SLA, SLO, and KPI. Okay. So all of that, the performance issues, the differences between the environments, for everything, right? For every section, we have a case study. We are expecting people to work on that case study. We are giving a case study and we are also giving you a capstone project at the end of the session where you will be able to read, understand, get more knowledge on every individual phase of performance testing life cycle, performance engineering life cycle, and you will clearly understand what is that is going to happen. Let's say if you ask me what is that application, you have some X application with Amazon, what is that big Indian festival sale, or there are some sales right from Flipkart and Amazon. Let's say festival traffic failure, application will pass in load test. In US, Black Friday readiness, any application you take, Puma, Amazon, Target, Costco, you take Walmart, any application, every year they are going to go with something called Black Friday readiness testing. You're doing application performance testing, which is passed, but during Black Friday sale, the response times will directly jump from 1 second to 15 seconds, 25 seconds. Root cause is database problems? I mean, for your understanding, there is cache miss, database logs, thread pool exhaustion, connection pool exhaustion, connection leaks. So SLAs, when you define SLAs, you have to not just consider only for your load testing, you have to consider it for peak traffic patterns, unexpected traffic spikes. Okay. Now, when it comes to test data, we will explain you why test data matters. Creating a wrong test data like user ID, user 1, user 2, user 3, dummy data will not help. Production data will have millions and trillions of users. They will have skewed access patterns. You will have hot products. There will be a use case where you have to test your application with unique data. When you're using it, when you're doing a test for 24 hours, when you're using a test for 24 hours, you have to when you have to use unique data, there will be a situation where you have to create 10 million records of unique data, which means that if you are using one employee ID, one PAN card number for uploading a profile in some company portal, you cannot upload the second resume because it is being recorded with your PAN number. PAN number is unique. If there is a use case, if there is a use case where you have to upload some millions of resumes, you will need millions of PAN numbers, which has to be unique. Else it will throw an exception saying that the PAN card number has been already taken. You cannot upload a resume with this PAN card. There is an existing resume, something like that. So even when you test an application, right, when you load test it, it is passed successfully. For example, one product like buying an S26 Ultra during S25 Ultra after the S26 launch in the festive sale, you have got a very good, discounted price. There is one product like S25 or post the launch of S26 Ultra, people are started buying S23 Ultra, S24 Ultra, which has similar options. Camera options got closed. Now, this particular product receives 80% of the traffic, right? When it is trying to pull only this specific product, what happens in a database? You will have a database index contention. I'll tell you what it is. When a table is working on a single product with all the traffic, the index will the database index of that specific product query will get continuously exercised. The database CPU can be 100%. There could be a problem with slow checkout. There could be problems with payment gateway. There could be a problem with payment getting successful, but order not getting placed. So this is where your production traffic patterns must be analyzed. You're doing load testing, your results are passing, but the right workload modeling with the right test data, you fail to miss, you miss it to test a specific scenario where 80% of the traffic is on one single product. Like the way I said, it can be S24 or S23 Ultra, where 80% of the users are targeting that. So when this is happening, you need to find out what are all the associated SQL queries or storage procedures that are relevant to that particular transaction when this is getting recorded. So when you send a request and getting a response back, how do you break down that particular transaction? You need to find out how many number of HTTP requests are invoked on the web server, how many methods are invoked on the application server, and how many SQL queries and data storage procedures are executed on the database server. So now you are identifying there is one SQL query which is actually which is actively part of selecting S23 or S24 product. This particular SQL query, when it is having 80% of the traffic on that particular transaction, this query will get executed millions of times. Okay, so that the database index contention will happen. So that is the bottleneck. Okay. Such bottlenecks We'll tell you how production traffic patterns must be analyzed. And when it comes to the analysis part, right? I'm not reading it, but you see the points when you talk about performance testing analysis, where you are putting some key metrics, important metrics in the report like response time, throughput, error rate, CPU, memory, disk IO. Now you are writing some correlation. People who are using load runner today, they're still merging graphs. There are ways, right? What are the three ways of merging the graphs in load runner? Anybody? You have three types of merging the graphs. What are they? You can hear me, right? I'm audible, right?
Yes, you are audible, but my experience belongs to new load.
Good, good. Sorry, you're saying something?
No. I mean, my experience belongs to completely new load. I don't
Okay.
know load.
So basically, there are different types of merging the graphs: tile, overlay, and correlate. Some few things will have common x-axis, common y-axis, and it will tell you what value increased with what. Sometimes you are merging running V users with average transaction response time to find out when I increase the number of users, what's happening to my average transaction response time, or what's happening to my hits per second, or what's happening to my errors per second. So many people will ask you, what are all the reasons for high response time? Simple answer is GC. Most of the world events explicit GC, or because of thread, if there is a deadlock, or if there is a resource contention, or if there is a request queue length that is getting increased, you will have high response times, high CPU utilization. Now tell me, even if you have less number of GC threads, you will have high CPU utilization. What are the reasons for low CPU utilization? Your CPU is only 25% on your application server. Now your response time is 9 seconds. Your CPU is looking very good. What could be the reason? This is what we will learn in performance test results analysis. How do we identify database logs? In case if you have a database log, if you have a network latency, if you have a specific thread that is blocking everything, or if there is a disk IO wait, there could be other reasons. I mean, you need to correlate. You cannot say that this is happening of this particular reason or particular metric. There could be so many other reasons why something is going bad. CPU alone cannot indicate system health. You need to correlate with memory. You need to correlate with disk. You need to correlate everything with JVM metrics again. Okay. Now, like that, we will be talking about memory leaks, out of memory errors, excessive memory pressure, excessive memory utilization. We'll also talk about the rate at which GCs are happening. We'll take GC logs, the rate at which minor GCs, full GCs, and major GCs are happening. Okay, we'll analyze the GC pass streams. We'll talk about the type of references. We'll also understand how to make an object eligible for garbage collection. Why do memory leaks happen? Why do you get out of memory errors within very short span of time with very less number of users? And day 5, we'll get performance environment. I'll explain you how to assess the environment. Okay, environment understanding is very, very important because today many of the people, right? I have experience in when I have 5 years, 7 years, 8 years, different years of experience, right? I experienced something like where I have been doing performance testing on 1/8, 1/16th size of what I have in prod. Not even I did not even test in 50% of prod. There are cases where I have tested 10% of what I have in prod. My environment is not even just 10% of production. So I'll explain you how to create a performance testing environment, why the comparison matters, why you need to test on identical environments which you have in production, what are the architectural components. When I talk about performance testing environment, I'll explain you the role of load balancers, load balancing algorithms, difference between having a load balancing algorithm and not having a load balancing algorithm, and why you will experience HTTP 503 errors because of load balancer. What is the role of CDN? How it is impacting the performance of your application? What is the role of DNS? What is caching? For example, you are opening an Amazon in your Google Chrome. You are a user with name Radha. You logged into your browser. You logged into your Amazon. You are using Google Chrome. If I'm coming tomorrow, my response is much more faster because my entry is stored in the local cache, which is a browser cache. Now my question, to save that local entry, Radha is coming within 30 days, you keep this in browser cache. If he's not visiting you again in this browser to the site called Amazon, you delete this entry from the browser cache. Do you know what is cache control? Where do you set the caching age? Come on. You have seen this one, right? For example, inside this call, you have cache control, you have max age equal to 3153600. I don't know what is this value, but let's say if you're giving 3600, right? 60 multiplied by 60, you have to give that value in seconds. So this cache entry, your record entry will be saved here for 1 hour. After 1 hour, it gets deleted. It will go to the server now. It will not take it from the cache. Again, not everything is taken from the cache. Okay. Only the static content which is being managed from the client side will be taken from the browser cache. You understand? There are various levels of caching which will be enabled from multiple places, from the application server level, database server level, browser level, everything. So in the architecture, we'll talk about caching, load balancers, CDN, and we'll also explain you the differences between traditional and cloud, how to set up an environment on-premise and cloud environments. And also we'll highlight the risks of testing everything on a smaller environments. And for everything, like you said, you have a case study. Okay. Now, we have already discussed about workload modeling. There will be so many workload problems with the wrong approach, with dealing with the huge amounts of production data, simulating that into performance testing environment. And like I have explained you, one product is receiving 80% traffic example. I'll tell you how to analyze this production traffic. You are having a Splunk kind of tool. You have a production logs. You have already an application there in production. When you have application there in production, you are taking 6 months web server logs, you feed them into Splunk, and you create a workload model. You will understand what user is doing at which user is doing what at what point of time, and how many times he is actually on that particular transaction at what time, and the percentage of activity. So inside workload modeling, you will go and analyze everything in Splunk. From the logs, you will design a right workload modeling. We are spending good amount of time on workload modeling. We will teach everything from the scratch, including what is business infrastructure workload, what is business workload, infrastructure workload, how do you need to simulate think time, user behavior, and we'll also give you the case studies. Okay. And capacity planning part, we'll talk about the capacity planning on how and when we have to do capacity planning, where the capacity planning comes in place. What is the role of vertical scaling, horizontal scaling? What are the parameters you have to consider, and how to do efficient scaling, and case studies. Okay, capacity planning, how to increase the number of cores, how to increase the memory, what are the parameters you need to consider, and everything we are going to talk there. Okay, coming to in-depth system performance analysis, we are doing interpretation on the user level, system level, OS level, and server level. So from the applications, from the application server operating system, database server operating systems, and like I said, many of the times, 20% of the bottlenecks you tend to see from web server, 25 to 30% of the problems you see from the application server, and the remaining 50% bottlenecks are directly from the database server. So if you ask me, if you want to increase the expertise level in performance engineering, many product-based companies will try to evaluate you in the expertise of databases. Okay, minimum to minimum, you need to know SQL, how to write a join. If you identify a SQL query, which is a problem, which is taking 10 seconds, at least when you open that SQL query, there is something called execution plan. When you type explain plan, you should understand what is that execution plan, where it is spending time. If your DBA is telling that we have to do some join optimization, at least you should know what is join, what is inner join, what is left join, right join, how joins are used to merge, bring the data together, how we are merging large tables. Okay, so because databases, right, they will give you fake, temporary, and hidden bottlenecks. Let's say you got a very big bottleneck today. Someone from the production user raised a concern saying that my database is experiencing 12 seconds of response time. You ask the time, and to know that, you take AWR report during that time. AWR report now will give you the data on what and why something happened in your database. It can be a temporary bottleneck which simply happened for 120 seconds when the user is trying to access something because of network congestion. That is temporary. Even if you're using Act FiberNet or any other fiber net, you will get there will be a network drop directly from 100 Mbps to 2 Mbps or 3 Mbps, where your network could be entirely slow for 5 minutes. I'm sorry. So when you are watching a movie, when you're streaming something, all of a sudden you will drop from 4K to 1080. The pixels gets changed because of the bandwidth that is available. So identifying when you raise a performance problem, is it fake? Is it temporary? And there are hidden bottlenecks. There are so many hidden bottlenecks. You know that 80, 80-20 rule? 20% of the inefficient code can cause 80% of the bottlenecks. You know that as a performance engineer. The developer who wrote the code knows it. But when you ask your stakeholders or development architects, they say that my code is working, don't touch it. Any simple change. Why we are doing multiple rounds of regression testing? There is a bottleneck. You fixed it. Now you retested it. The bottleneck got fixed. But why you are doing regression? Multiple rounds of regression. That particular fix will start directly showing some negative impact on the other existing functionalities which are working as expected or which are within the acceptable limits. You have login, search, add to cart, make payment, log out. There is a problem in the search. You fixed it. Now the search transaction is less than 3 seconds. Now add to cart is giving 9 seconds. The reason is this particular change that you're implementing on a specific source code search transaction is showing, is impacting the functionality of add to cart, which is already working fine. Now again, you're doing end-to-end testing. This is an iterative process. So there will be so many hidden bottlenecks in the source code where you need to enable code profiling. I'll tell you one point. With very less number of users, you are experiencing so much of CPU. You know the reason why? There could be one function inside your source code. There could be one or more functions called together are just simply the reason for 80% of the CPU utilization. You need to find out that function. How do you do that? Only by code profiling. The reason why you use JProfiler, your kit profiler, or JConsole, or the reasons for using JProbe, JMC, Java Mission Control, JFR. These are the tools which will assess the code. It will identify the hotspots. It will tell you which line, which method, which function, which object is actually the problem. Similarly for .NET, you have Redgit Ants Performance Profiler, Redgit Ants Memory Profiler, you have CLR Profiler, you have MEM Profiler, you have Perfview. There are so many tools available and depends on the cost aspects. Okay. And the Windows performance monitoring, I always want to explain this one. Today, there is a tool, I was explaining about something called every operating Windows system, right? You have a inbuilt utility called Event Viewer. Inside this one, if you go to custom use, or if you go to Windows logs, inside your application, it is going to give you every single activity that is recorded. Okay, let's say you're running a test, you don't have a monitoring tool. Now you go and filter your current log. If this, assume this is your application server. Now I want to see only the errors that I got. When I click on this one, these are all the errors. I see an error in a .NET runtime. .NET runtime is installed here. Okay, there is an application hang. If you open this one, this happened on 11th March 2026 and it happened at 9:48. Okay, with some installer. If you open this one, it will have the event ID, it will have a log, it will have the server name, the user is system, the device is not a supported system, aborting installation, the application hanged. Okay. Likewise, when you test, right, if your application server is a Windows server, your database server is a Windows server, during the time when you have installed your test, you can go here and you can see what are the different, see, you have so many different, you have so many errors from .NET runtime. .NET runtime is continuously exercised when your .NET application is tested with load. Okay. So likewise, inside that, we will tell you why application is slow. If your load testing is load test tool like load runner or JMeter is showing you 10 seconds of response time, will tell you where is the problem, what you have to check, what is that perfmon, how to, when you say CPU utilization is 90%, inside that you'll have so many metrics. Let's say you simply go to perfmon. When I say CPU utilization, right? You need to understand the CPU. Like if you go to task manager, inside the performance tab, if you go to CPU, you can simply say that my CPU is, it has 8 cores, 16 logical processors. But if you want to go and see what's happening in my CPU, you have to go to resource monitor. Inside the CPU, you can see which one is consuming most of the memory. I'm giving you the class over Zoom. This is the process ID. This one is running. And this is the highest system after system with 452 threads. A Zoom application with zoom.exe process name 20324 process ID is having 303 threads, but the CPU utilization is only 2%, which is good. This is the CPU total. This is the CPU used by services. and you can see all the CPUs. When you have 8 logical processors, it means that you have 8 cores. It means that you have 16 logical processors. CPU 0 to CPU 15 or 16 logical processors. And every logical processor, if you see, you can see one thing in common. You are seeing every processor, every logical processor is active. Something in green in color. It means that every logical processor is working. If in case if you don't see anything in green color, it means that in case of hardware failure, in case of any of the logical processor is not working, okay, you can go and see why your CPU utilization is high, why your CPU utilization is low. And coming to the perfmon, when people say my CPU utilization is above 90%, what are the metrics you monitor? Percentage processor time total. When I say total, right, it is going to add all the instances. You can see 15. When you have 8 cores, each core has 2 logical processors. 8 multiplied by 2, 16 logical processors is what you got. You want to know the CPU utilization only on the logical processor number 10, you can select this one. When you say total, right, it is going to give you the utilization across all 16 logical processors. When you have 90% CPU utilization, what is percentage time, what is interrupt time, what is privilege time, processor time, user time, and there is something called processor queue length, which I'm not seeing here. So there are multiple metrics, interrupt time, idle time, every metric I'm going to tell you, and I'll explain you how to add that to identify those performance issues. Okay. And coming to the day 10 part, we'll talk about the Linux performance monitoring. We'll install something like CentOS or Red Hat with version 9 or 10.x, and we'll give you some of the most important Linux performance monitoring tools. And I'll also tell you how to create Oracle VirtualBox, or I'll also tell you how to install WDL, Windows Distribution Linux, which is a utility where you can install Linux on your existing Windows operating system. Now, from here, we will talk about JVM part, JVM and .NET performance issues. Most important part, which is an application level tuning. Don't worry about how these things are taught. Everything we have is set up. We will show you the bottleneck. We'll make you to create your own environment. With your own hands, you can create application server. You can deploy the application. It is not a simple application like JPEG store. It is not a JPEG store. We have multiple applications. It is not a web tools like application. We have a Eep shop on web, which is a real application. We have a SailPoint application, identity application. So that application level tuning, all the Java issues like memory leaks, GC passes, connection pool exhaustion, thread pool exhaustion. For example, if you have a high CPU utilization, if your application is getting slow every 5 minutes intermittently, if your root cause is full GC pass for a Java application, that's on the other side. If you take a .NET application, right, like Java, where you got young generation and old generation, hidden multiple server spaces, then old generation meta space. Similarly in Java, you have similarly in .NET, you have small object heap and large object heap, generation 0, generation 1, and generation 2 collections. I'll also show you how to configure the INET manager, which is an IAS server where you can deploy your application, and how you can work with the different application pools, and what are the settings that you can what are the settings that you have to do on application pools, and how to start the application is what I'm going to tell you. So there are multiple applications that will be deployed, and when you click on browse, I'll also tell you how these applications will work. There will be different exceptions that you will get to see after the deployment of Java and .NET application. When application slows down over time, We will explain everything step by step. Okay. So that is what is written over here. So don't worry about what is being written on the data, I mean, the slides part. This is only for your understanding. And the primary aspect of GC for improved performance will also give you all the different JVM settings, JVM flags that are required to fine tune the GC, how to take multiple GC logs, how to enable GC logs, how to monitor GC logs, and different GC algorithms, the impact. When I say different GC algorithms, serial GC, parallel GC, which is also called throughput GC. Then third one is CMS GC, concurrent mark and sweep. Then the fourth one is G1 GC, garbage first. Then Shenandoah GC, Epsilon GC, Jet GC. And with the recent Java JDK 23, I'm seeing something called generational GC. All the GC algorithms, their impact will tell you how to choose the best GC algorithm for best performance in your Java applications performance testing. And what are the differences, use cases. Example, if your CPU on both application server and database server is very high, is same, let's say 80% CPU is what you're seeing on application server, 80% CPU is what you're seeing on the database server. So which one is the problem now? Both or application server or database server? Can anybody tell me? You understood my question? 80% CPU on application server and 80% CPU on database server. Where is the problem? Both or fixing something on application server will fix the second one? Yes? Anybody? Okay. So there will be many reasons with slow queries, missing indexes, full table scans, locking. So we'll also explain you multiple Oracle, I mean multiple reports on databases. We'll tell you on how to implement threat management, wow use of the synchronization, explicit logging. So efficient threat pooling, what are the different problems with threats, how to take heap dumps, what is that you have to analyze, how to take threat dump, what are the parameters you need to consider, what is that you have to fine tune. And also we'll talk about the concurrency control. And coming to the JVM monitoring, right, there are various tools, every tool that is available. We are going to talk about Java Machine Control, JProfiler, YourKit Profiler, JMap, everything we'll talk, every GC pattern. And remember, even if something is missed, we will cover up every session. I'm sorry, every session got its own importance. I mean, the way we create the course. Okay. So if you see, there will be some structure like this. If you take a session, the session and each of the session you will get a questionnaire part, something like this. Everything whatever we have discussed, we have a questionnaire part. Okay, for every session we have a questionnaire part. We would expect the participants or people who join these sessions for learning, we expect them to work on all the questionnaire part. And we'll also connect multiple tools. Let's say if you have a question on how we are explaining, let's say there is one server of mine. So this is one monitoring tool that we got. Okay, when we load test, we'll monitor the instances. It is a tool like New Relic Datadog. This is called Managing an Apps Manager. The one which we have installed, you can go here. We have configured agents for multiple databases. This is Tomcat server. Then this is Postgres server. When you install this application manager from Manage Engine, by default, to install this application manager tool on a specific host, right? By default, it will use Postgres SQL database. The prerequisite of installing Manage Engine Apps Manager, it will first install Postgres. Okay. But for my database, Oracle, if you see, there are some alarms that have got triggered. I have created some 40 GB of data. I'm making my database shaky with some random scripts where I'm infusing some bottlenecks, intentional bottlenecks, to see the performance of my database. Like if you see the performance, the response time, number of sessions, database buffer hit ratio, not just that. Okay. When you go to the Oracle database here, now you can see lot many things. Like you can see the utilization across the pluggable database. You can see the table space utilization. These are all, if you see the tables, right? These tables with perf_test2, perf_test1, these are all the tables I have created with so much of data. Okay, so much of data I have created. You can also configure alarms, and each of the table, right, with how many reads it got, how many writes it got. When you install any database, you can, now there are scripts available to generate some load on your database servers. There is no specific load testing tool which will be required to generate a load on the database. There are certain SQL queries which will generate some artificial load on your database, and they will bring some abnormal numbers on the database. So how these things will help you when you take AWR reports, ADDM reports, there will be some problematic data that will be available, which is saying something. For example, there is a problem with PGA, Program Global Area. There is a problem with SEA, System Global Area. There is a problem with buffer cache hit ratio. Or it will tell you some of the queries are very problematic, which are taking high CPU, high memory, high response time. Now you see, there are read time, lots of information is there in the table space. There is also one report called ASH, Active Session History Report. It is going to talk about all the sessions that are part of your database. There are 64 sessions. How many of them are inactive? How many of them are killed? How many of them are cached? You can see the complete information. So for example, for a very simple level understanding, why you need to take ASH report on a database. All of a sudden you noticed there is a spike. You're running a test for 2 hours. After 1.5 hours of test, there is a 90% utilization of CPU on your database server. Then you will take ASH. You know why? All of a sudden there is your CPU jumped from 35% to 90% for 2 minutes, and you will take ASH report, which is active session history report on Oracle database, to find out which session is the reason for creating that CPU. Okay, there could be one session which could be the reason for spiking up the CPU. Okay, and it will tell you what is the problem. And coming to the performance, right? As I don't have any data, I don't have any active long query running queries here, inactive long running queries, and there are other SQL queries. You can see along with the SQL ID, there are certain SQL queries where you can use all the SQL queries to assess, to analyze. Okay. And if there are any rollbacks, corrupted blocks, you can see here. And SEA information, the utilization of SEA here, the utilization of, if you have any logs, right, you'll be able to see that logs. To view the Oracle blocked sessions again, you have to enable something from the Oracle database configuration, as well as you have to do some changes on the application manager. The jobs, backup jobs, PGA, the processes, ASM, and even if you want to take something like AWR, the SQL developer, right? If you see my database, very simple. When I create a database, when I have so much of data inside my database, when you're doing a load testing, if you go to ASH in AWR, if you click on last AWR report, you select the database here, and when you click here, it is going to take an AWR report. Okay. So likewise, we are going to talk about so many things. Okay. This operation is not being performed at this point of time. This is a licensed version. Okay. There are other ways. Similarly, you got something here. This is an ASH report. You can copy, export it, and you can active session history report. You will be able to understand which session is actually taking most of the time, and you can interpret things from here. Similarly, for SQL Server, we have a SQL Server Management Studio for the multiple databases. We will connect to the database, and we'll also show you things like this. If there are databases like this inside FMS new, inside programmability, we also have problematic SQL queries. Okay. Stored procedures. This is a stored procedure. When you click on execute, you can see the time that it is actually taking here. You can see the count of seconds going high. So when this is going high, now there is a stored procedure that is getting executed inside a specific table of my application. It has taken 16 seconds to retrieve how much data? 1742 rows, which is very small amount of data. This particular stored procedure is actually a problem. Okay, display execution plan. You can see the execution plan here. This is what is the execution plan. You can see the complete plan here. That's what you should at least learn SQL part to understand what is explain plan. So like this, we have to monitor. You also have activity monitor to see the recent expensive queries. These are all expensive queries. So to see all of that, we have every setup in place to show you the Oracle database, SQL Server database, to show you the monitoring related aspects. Okay, from JVM monitoring, and coming to the heap dump and thread dump, also we have multiple thread dump and heap dump analyzers. I'll show you something in the technical demo tomorrow. So we'll explain you how to analyze different problems from JVM, from .NET, from heap dumps, from thread dumps, all from performance point. For example, I'll ask you a simple question. When you take a thread dump, what is the most important section you will look at? You have taken a thread dump for the very first time, or in interviews, people are asking you, you have taken a thread dump. They'll ask you what is thread dump, why do you take thread dump, what is the interval at what rate you are going to take thread dump. When you take a thread dump, why thread dump? Why do you need to take a thread dump? In case of high CPU or high response time, if your application server is freezed, application server becoming unresponsive, then you will take thread dump. Thread dump reveals what? Thread dump reveals if there is an application deadlock, if there is a resource contention, you will get to know that in deadlock. I mean, in thread dump. Now, in order to what you look in thread dump, you look for blocked threads, first thing, then waiting threads, then third thing, running threads. Why do you need to worry about running threads? A thread which is continuously running without getting terminated will be one of the reason for high CPU utilization. A thread has to do its work and it has to terminate and it has to start again. Right? Now, if there is a deadlock, if there is a resource contention, how do you get to know? There is an important section called stack trace inside your thread dump. From the stack trace, it will tell you which line of the code, which method is actually the problem inside your source code that is creating a deadlock. Now, sequentially, if you go and you're performing RCA root cause analysis, how do you fix a deadlock? What is the fix for deadlock? Do you delete an object? Do you delete a thread that is creating a problem for deadlock? No. There is one solution for that. So likewise, the hierarchy is designed. We'll discuss so many case studies on JVM and .NET. We'll talk about thread pool limits, connection pool limits. We'll talk about memory leaks. We'll talk about log analysis, analyzing bottlenecks. Okay. And for everything, we have got different case studies, lab setups, and we'll talk about some high-level information on the emerging tech stack. And like JVM in Java, you have CLR in .NET, you have PVM in Python, which acts as an execution engine. So we will show you the complete deployment of installing the application server, web server, application server, database server, uploading the data, everything. And finally, we'll come to, we have already shown you the database, right? Finally, we'll talk about the best practices. What are the best practices? There is no best practices, okay? We will talk about best practices, but any small change or minor configuration change that is giving you the best performance, that becomes the best practice. The same thing that you have configured for your application, for your system integrations, that may not work for my application. This is the logic. Increasing the heap size is not the solution, is not the best practice. Best practice is you have to create a performance testing environment which is identical to prod, which is the mirror image of prod, which is the exact replica of prod, including configuration parameters, including values, including everything. That is the best practice. But the reality, ground reality is what? The customer says, I don't have money. Do it on a shared environment. Your automation activities are done, ETL testing activities are done, functional activities are done, and on top of it, you have to do performance testing. Half of the component's existence is not available and compared it to prod. Right? Monitoring best practices, everything you have to monitor. Every value that gives you or tells you what is wrong, you have to monitor that. Okay. Database, like I have shown you, we are dealing with three main databases. One is SQL Server, Microsoft SQL Server, Oracle MySQL, and Oracle Database 19C or 21C. Okay. The last one, I will talk about the client-side front-end performance. If your application page is taking 8 seconds to load, the backend time is only 1 second. The remaining 7 seconds is the problem with large JavaScript files, the image sizes, multiple DNS calls. So we'll teach you tools like developer tools, GTmetrix, web page test, everything. Okay. So GTmetrix, and I'll also tell you the role of DNS, how to minify the problematic CS calls and JSS calls. And we will show you different tools on how to assess or how to reduce the response time from 6 seconds to 1.2 seconds. So performance engineering is all about analyzing the entire stack. I'm good at database, I'll find the bottlenecks only in database. No. Client side, you need to know the OS concepts. You need to know the Linux. You need to know core Java, not entire Java. Need to know core Java. At least after learning core Java, you'll get the document, top 100 questions that are asked in product-based companies in the first round. Many big companies from products, right? Like Salesforce, ServiceNow, McAfee, these guys will ask Visa, they'll ask the hacker rank round. They'll ask the same question for performance engineers, top 100 Java programs. If you're cracking, if you're trying to work out all the 100 problems, top 100 Java problems, right? Even after 2 years, the hacker rank will give you only that 100 performance problems, Java problems. For performance engineers as an eligible criteria, as a round 1. So by the end of this program, if you ask me, these are the tools that we are going to cover. If you ask me what is the end result of this course, by end of this program, you will be able to diagnose all the performance problems across the entire system stack, be it front end, be it application, be it operating system and the database. So you will have that ability, you will gain that ability to troubleshoot the real performance problems. And the main agenda is to make you interview and industry ready, because many of the people are they are exposed to so many other concepts, but on how they're not sure. So when it comes to interest rate, you're asked many things in many different ways. So production issue handling, now there is a mix and match. They're asking you the questions from production incidents. They're asking you from SRE level. They're asking you from observability level. They're asking you performance testing, performance engineering. Some of them are asking code profilings. Some of them are asking how do you do some troubleshooting if you have a problematic SQL query. How do you optimize? How do you rewrite a query? Some people can ask you. How do you optimize a SQL query? How do you rewrite a query? They can give you a query and ask you what is that you can see if something is wrong. Or they can ask you like explain the execution plan of the SQL query or stored procedure. So there will be a lot of questions. For example, like what causes low CPU but high response time? Why does an application scale only with 8 cores? Why not with 16 cores? From capacity planning. Why is the system slow only at the night time? Only from 11 to 12 o'clock, why your system is getting slow? So all these questions, right? You need to know different patterns, wrong workload, database bottlenecks, thread pool, connection pool issues, caching problems, network problems. So all these things, right? We will go one by one. We'll go slowly. If there is a pause, if there is something that has to be stopped, if you need more information, we'll take it. Not to worry. And this course will give you some good experience. Okay. That's all for today. And thank you very much for taking time and joining the demo session. And tomorrow we'll have a technical demo and you'll understand how this training will be going forward. Okay. All right. Thank you again. Thank you very much for your time.